Block diagrams are commonly seen in many fields such as control systems and signal processing and signal filtering. And a tool to simulate a block diagram is incredibly useful for finding out the performance of a system. So here we will be demonstrating a WebGME plugin that takes a model and generates output Python code for simulation of block diagram models. So to build one, you would drag into the root a clock. You'd give it a name and some sort of time interval, example, and say we're gonna have 10 seconds here. We're gonna enter it, and then the user would put in various blocks to do a simulation. So they would drag them in. They'd specify criteria like a gain of 10 maybe. They'd connect the blocks. As such, where the output is recorded in the recorder, which you can specify whether you want to output it in the console and what name you want to show up in the graph, if any. For example, example, and then the title of the graph will be sample. And then they'd check the constraints, and it meets the constraints, so it's ready to be built. So then you'd return to root, run Python SimGen to generate an output, which is a zip containing all the models present here. Now to show off what it can do, there's three models here, one of which is a basic closed loop, where we have our closed loop here, which generates one graph of our control effort and our output, and another graph where we demonstrate what adding noise to the signal would look like. Then we have a more complicated control, which is a PID. So we have our P, our I, and our D, our feedback loop, and then our model of our system itself, which we then measure the output in a graph. And then one more common system seen in control systems is an observer. This one is observing a offset sinusoidal wave. Here's our model of our system. Here's the observer itself. We set the initial states to be incorrect, and then we measure the output and then the estimated output in a graph. So, returning to our results, we have a zip of all of our models, which we then extract. We extract two models. And in models, we already have blocksim.py, which is the library that allows our simulations to run. So we choose a model to run. For example, we will do closed loop. And here you can see the output code in the console, or the output of y in the console. And then you can see the loop itself over the 10 seconds. And then we can go to our next figure, where we have the output with noise added to it. Then we can run a different one. For example, the PID control. And we can see our controller quickly gets us to 1 over the time interval. And then we can also showcase the observer. And as you can see, we have our function itself, this y, and then we have the observer, which we can pan around with. You can see it overshoots and then it matches the actual output. So in short, a tool such as this for generating simulations in Python out of a block diagram is incredibly useful for viewing the performance of a system. Hopefully you'll find some use out of this.